which is Mathematical Literacy. My name is Mithala Chia. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pakama Research and Development. Grade 12 learners, it's good to be back after the recess. Our main topic today will be focusing at probability, and the section that we'll be focusing at, it will be probability expression and representation. Boys and girls, let's see. I think you have already done this probability section in class, whereby your teacher has already introduced it to you. Actually, you have done probability from grade 10. It's not for the first time you're doing it today. Now, what is our lesson objectives? What is it that you need to know by the end of this lesson? You should be able to define probability, express probability in different forms. Remember, we need to be able, after defining it, we need to be able to express it in different forms. Work with probability scales. Recognize the terms used in probability. Also, draw and analyze contingency or two-way tables and tree diagram. Boys and girls, this topic is so simple. If you know it, you'll be able to answer all the questions based on this topic, because you'll find probabilities there in paper 1 and it's there also in paper 2. So you won't find it in the exam question as a standalone question, whereby you can say question 2, it will be based on probability only. No, but it will be integrated amongst the questions. So our first point of depart, let's see, where do we start? We said we should be able to define probability. Let's look at the terminology that you will find in probability, terminology that you need to know, because once you can understand this terminology, it will be easier for you to interpret the probability question. Now, what is probability? It says it is the numerical measure of the likelihood or a chance that an event will happen or not. So we say it is a numerical measure of the likelihood of a chance that an event will happen or will not happen. Then we have what you call an event. I am going to go through all these terminologies so that as I explain now, you understand when I say probability is the measure of the likelihood or a chance that an event will happen. So you need to know, when we talk about an event, what are we referring to? With an event, we are referring to an activity. So it means an activity must be carried out for us to say there is a chance of something happening or not happening. If an event, let's take an example. We can say a game between Kaizer Chiefs and Mamelodi Sundowns. So once we talk about a game, it's an event, it's an activity that is going to take place. We know it's a game, it's a soccer match between the two teams. And then we have what you call the outcomes. What are the outcomes? What are we expecting from that event? We are expecting the outcomes. And what are those outcomes? Outcomes are the results of a trial. So that means the two teams need to play. So the results that we'll get at the end of the game, that will be our outcomes. And then we go on, we say a trial. Remember, we said the results of a trial. The outcomes are based on the results of a trial. So now, what is this trial that we are referring to? A trial is the act of letting an event happen or not happen. For example, action of tossing a coin. So if I toss a coin, I can either, remember tossing a coin, you throw it on the air and then you expect the results to come out. So there are only two results that we can get, which can be a head or a tail. You won't get both head and tail at the same time, unless maybe you are tossing 2 coins. But if you are tossing only 1 coin, your result can be either a head or a tail. So if it is a game, let's go back to the game of Kaizer Chiefs and Mamelodi Sundowns. Remember now, a trial, they will be playing for a period of 90 minutes. So at the end of 90 minutes, then we get the results, which are the outcomes. So we say, okay, fine, they have played, and then the outcomes are these ones. So that is why I'm saying with the trial, they need to play before we can get the outcomes. Now the chance, when we talk about the chance in probability, we say it is a possibility of something happening. So remember, as they are playing, as the 2 teams are playing, remember now they are going up and down, kicking the ball. It is an act of what? Of a trial. And then something can happen. A chance of them scoring. A chance of Kaizer Chiefs scoring, or a chance of Mamelodi Sundowns scoring. So we say there is a possibility of a chance happening. Now, what are the possible outcomes from that game? So now as they play, as they go on a trial and activity taking place, and then now we say there's a chance of something happening. What is that something? There's a chance of either Kaizer Chiefs or Mamelodi Sundowns scoring a goal, and then we say, okay, fine, the possibility or the possible outcomes, we say it is the chance that an event will happen. Possible outcomes. So possible outcomes, that's when we say, okay, fine, Kaizer Chiefs can either win, lose, or draw. Same applies with Mamelodi Sundowns. Mamelodi Sundowns can win the game, or they can draw with Kaizer Chiefs, or they can lose the game. So those are the possible outcomes of an event now. And then the impossible outcomes, when you talk about the impossible outcomes, remember I was talking about tossing a coin. As I toss a coin, throwing it up on the air, I expect a result, the results. So the results that I'm expecting, it can either be a head or a tail. But it is very impossible for me to get a head and tail at the same time if I am tossing only 1 coin. But if I'm tossing 2 coins, then 1 coin can either go to head or flip into head, and the other one can flip into tail, or they can both be on tail, or they can both be on head. So that is what I'm saying. We say there are impossible outcomes, there are possible outcomes. So the impossible outcomes, it is the chance that an event will happen. And then with an impossible outcome, we say no chance of an event happening. That is what I'm saying. If I toss a coin, only 1 coin, then my results that I can get, it's only 1. It can be both. I can't get head and tail at the same time, but I will only get 1 result. So we say it is impossible to get 2 heads, or maybe to get 2 heads, or to get 2 tails. So it's very impossible if I am tossing only 1 coin. Now, with certainty, when we talk about certainty in probability, now here we are saying we are very certain, we are very sure that something is going to happen. When we talk about certainty, when we are certain that this is going to happen, we are very sure. We say something is going to happen. So for example, let's see the weather outside today. It's very cloudy, but the cloudiness, there is sun, it's partly, so it's not that cloudy, it's partly cloudy, because you can see somewhere there are clouds, somewhere it's clear. So that means there is that chances of something happening. So we can say, we are saying if it's cloudy completely, there's no sun at all, then we say it is very possible that it's going to rain. So we are very certain if there are clouds and there is no sun at all. But now, if there are clouds, and somewhere in the clouds you see that there is the sun that is rising there, or that is shining there. Then we say, oh, okay, fine. Now with this one, we say, 50-50. It can rain, it cannot rain. So there are people now whereby maybe wherever you are, it's shiny. The sun is shining, it's hot, there are no clouds. So if I ask you, is there any chance of rain today? Looking at the clouds outside, looking at the sky, there is no sign of clouds, then you can say, it's impossible. But if there are clouds, we say, okay, it's very possible that it can rain. So now, quickly going back to what we have just explained, or that we have just went through, let's have a look. We said probability. Before I can leave this slide, we say probability is a numerical measure of the likelihood or a chance that an event will happen or will not happen. And I've already explained to you to say, when we talk about an event, now we are talking about an activity taking place. So it means when we say probability is a chance that an event will happen. So we say there is a chance that an activity is going to happen, meaning a game is going to play. So between the two teams. And then we say now an outcome. Outcome is the results. So what are we expecting from that game? We are expecting the results. What are those results that we are expecting? We are expecting either a win, a lose, or a draw. Meaning one team can win or lose or draw. Those are the outcomes that we are expecting when there is a game between Kaizer Chiefs and Mamelodi Sundowns. And then a trial, that's when they are playing for 90 minutes, kicking the ball up and down. So as they kick the ball up and down for 90 minutes, we say they're taking an action. So we are saying with the act of letting an event happen or not. That is a trial. So meaning an event of an activity there. And then we come again, we say a chance. A chance, we said, is a possibility of something happening. And then the possible outcomes are the results that you are expecting. The chance that an event, possible outcomes, we say it is the chance that an event will happen. So we'll get the outcomes. Impossible outcomes, those are the impossible, meaning that it won't happen. So there is no chance of an event happening. And then when we are certain, then we know that something is going to happen. We must know that now we are certain. Let's continue with our terminology. When we talk about the likely now, this is the terminology, boys and girls, that you need to know in probability, because there are questions that are based on that terminology. So you need to be familiar with this terminology. What do they mean when we say likely in probability? What are they referring to? We say with likely, chance of something happening is greater than the chance of it not happening. So when you say something is likely to happen, so that means there are greater chances of an event happening. It says chances of something happening is greater than the chances of it not happening. And then when we say it is unlikely, we say chances of something happening is less than the chance of it not happening. Chances of something happening is less than the chances of it not happening. If they are even, it's 50-50. So even we say, when we say 50-50, we say chances of something happening or not happening in the same time. So let's take maybe, for example, going back a bit, with the likelihood or with likely of something happening is greater than the chance of it not happening. If maybe your teacher is telling you that tomorrow you might write a short test or a baseline test, then we know that if the teacher is there, there is a greater chances of us writing that test. It won't be less, but there is a greater chances. And then if the teacher is absent, listen to me, I said to you, the likely part, we say, if tomorrow the teacher is telling you that tomorrow you'll be writing a baseline test, then you know that if the teacher is there, the chances are greater for you to write that baseline test. But if the teacher is not there, then you say, we didn't see Mr. So-and-so or Mrs. So-and-so, then there are less chances of that event not happening, meaning there are less chances because you did not see Mr. So-and-so, your class teacher, or maybe your maths teacher, you did not see them in the morning. Then you say the chances are very less that we can write the test today. And if it's 50-50, because now we don't know, maybe your teacher left the papers with another teacher, the colleague of theirs, and then they said, ma'am, if tomorrow I'm not coming to school, please give my learners this test to write. But if I'm there, then they will write. So even if I'm not there, or I'm not sure whether I'll be in tomorrow, I'm not sure if I won't be in. So it's 50-50 chances that tomorrow you might write, you might not write. It depends on the presence or maybe on the arrangement that the teacher has made. If maybe they did not leave anything for you to write, then it won't happen. But if they've left the papers for you to write, then it's going to happen. Now, coming to the predictions. Boys and girls, when we play Lotto, okay, let me just read the statement first for you. We say with the predictions, statement describing the chance of an outcome to happen based on given information. Prediction, we say it is the statement describing the chance of an outcome to happen based on given information. Boys and girls, we know that when we play Lotto, it's predictions, because we don't know which numbers are going to come out. So you just make a bet, then you place the numbers. So it's predictions. You predict because you don't know. You predict that these outcomes or these numbers are going to come out. That is the prediction. We are not sure, but we are just predicting. As we continue, boys and girls, now we go to our tree diagram. Don't worry, I am going to show you the examples of everything that I'm talking about in terminology. So the first step, you need to know the terminology. You need to identify these terms in a question paper so that you know what do they mean when they talk about this. And then a tree diagram. With a tree diagram, boys and girls, we are not talking about a tree that you see outside that has got the branches. Yes, it's a tree with the branches, but not that one, not the one that you are seeing outside. But we are saying a tree diagram, it's a diagram using branches to display all the possible outcomes of the events. A diagram using branches to display all the possible outcomes of the event. That is a tree diagram. Remember, a tree has got some branches. It will have a tree trunk and then some branches. That is why we say it is a tree diagram. So the possible outcomes will be written around the branches. You'll see the example when I show you. And then we have, again, a two-way table. A two-way table, also known as a contingency table. It represents all the possible outcomes of two trials taking place at the same time. So a two-way table, it represents all the possible outcomes of two trials taking place. If I toss two coins, that means I will get the results on both coins, not only on one, but on both two coins. So now I'll get the results. Then we say now, the results maybe tossing the coin for the first time, these are the results from coin 1 and coin 2. Tossing the coin from for the second time, these are the results from coin 1 and coin 2 for the third time, and so on. It depends on the number of trials that you are going to take for you to get the results. We have also experiment. With an experiment, it's a series of trials. Remember what I just said now. I said to you, in a two-way table, we toss 2 coins, and then tossing the 2 coins. So we'll toss these 2 coins for the first time. That means it will be for the first trial, and then we toss it again, second time, third time, fourth time. So a series of those trials, we call them the experiment. Because when you talk about experiment, you can't say, I've tried to do this once, and then you say, I was experimenting. For you to experiment, you have to do it over and over again to see if the results that you are getting are favorable or not. So it is a part of a series of trials. Then the experiment, that's when you get the results. Expression of probability. Coming to this one, remember probability. We don't just say, okay, fine, probability is likelihood, numerical likelihood of chance or a chance of an event happening or not. So, but this, after that has happened, after the trials have taken place, then we need to express these results. So, expression of probability, the number of experimental results divided, so meaning the number of the experimental results divided by the number of experimental results possible. So now, if I toss a coin, I will get the results. It may be tossing 1 coin, I'll get the result. It will be a head. But if now I am tossing a coin, I know, okay, I'm expecting 2 results. I'm expecting a head or a tail. I am not expecting head and tail at the same time because I'm tossing only 1 coin. I am not expecting head and tail at the same time, but I'm expecting a result. So we say it's number of experimental results divided by the number of the experimental results possible. So there are 2 possible answers. It's head or tail. But I can only get 1. I won't get both. If I toss a coin, I know the results that I'm expecting can be head or tail. So, but I won't get them at the same time. So there are 2 chances, possible outcomes. It's 2, but we know that the result will be 1 because I am tossing a coin. So if I'm tossing a coin, if it says head, and then I know, okay, fine, it's head, but what I was expecting is either a head or a tail. So it means it is 2 possible outcomes, but only 1 outcome. I hope you understood this terminology, boys and girls, because in the paper, you are going to come across this. They might say, explain probability. What does the word probability mean? You should be able to define it in the exam. And remember, boys and girls, this is one of the topics that is so simple. You are collecting the marks here. That's where you collect the marks, because you'll be given the scenarios and then you'll be answering based on what is given to you. Now, let's have a look at the probability expression concept. What are we referring to? We say the probability of an event happening is expressed as a number. So now this number, probability of an event happening, is expressed as a number. And now this number, it cannot just be written as a number. Maybe you say 2 and then you leave it there. No, there's a way that we need to write this number. It can be written as a fraction, number 1. So what do I mean when we say probability can be written as a fraction? So it can be written as a fraction, meaning a half, it's a fraction. And then as a As a decimal fraction, then it can be 0.5. It's a decimal. As a percentage, it can be 50%. As you can see, as a fraction, it's half, it's 1/2. As a decimal, it's 0.5. And then as a percentage is 50%. So if they want you to write your answer as a percentage, your probability as a percentage, then you leave it as 50 or maybe in a percentage form. But you'll see when we do the activities, how do you write that? Because now, remember we said half. It will be an event happening, and then now we get the results. Then we say, how did we get to this half? Let me just do this. How did we get to the half? We said it's 1/2, and then we multiply it by 100%. That leaves us with 50%. This is what we are expecting you to write. So if it is it's a decimal, then you check, okay, fine. Half fraction, I got this answer as a half, 1/2. And then 1/2, we say 2 goes how many times into 10? Remember, now we'll be putting 10 there. This one, let me just do this so that you can see. A half here is the same as 2 goes how many times here? Remember, we'll be putting a 0 there. We say 2 goes how many times into 1? It doesn't. And then you get a 0 comma, and then into 10 it goes 5 times, and that's where our 0.5 comes from. So if you get your probability there, they say write your answer as, or leave your answer as a decimal fraction. This is what they are expecting you to write your answer as. And then as a percentage, this is the answer that they are expecting. And then you look at the mark allocation. If, say, suppose it's 3 marks, then you know, okay, now they said I must leave my answer as a percentage. That means I have to show all these calculations for me to get to the percentage, and then I get my full allocation of marks. Now, probability must always be written in its simplest form. So what do they mean? They say you can, for example, if your answer, it says 6/18, there are 6 possible outcomes out of the total number of 18 possible outcomes. So it means we got 6 results out of the 18 possible outcomes. And then you can leave your answer like that in this fraction of 6/18. But you have to simplify it further. Leave it in such a way that you are not able to simplify it further. You leave it in its simplest form. Like 6/18 is the same as 2/9, because we know 6 goes here, it goes twice, 6 into 18. So you do the 3 goes sometimes into 6, it goes 2 times, and then into 18, it goes 9 times. So that's what you are doing. Boys and girls, the probability of events can be expressed using a probability scale. You will see on the next slide, I will show you that scale, but you need to understand this scale. We say it is a probability scale. The scale ranges from 0 to 100 or 0 to 1. Meaning 0 to 1, they can give you that scale of 0 to 1, or they can give you the scale of 0% to 100%. So if it is 0% to 100%, you know now we'll be talking about the percentages. It's 0, then it's 25, it's 50, it's 75, then it's 100%. If it's 0 to 1, then it is 0, and then it is 0.25, we have 0.5, and then we have 0.75, we have 1, if we are using that scale. So what does the 0 stands for on a scale, on a probability scale? The 0 stands for an event that certainly will not happen. So if there are no chances at all, that is 0. We know that there is no chance. 0 stands for probability of an event that certainly will not happen. So that means it will never ever happen. If I may make an example, I know you're going to laugh at this one. If I ask you, is there any chance that a cow can give birth to a chicken? No ways. A cow, it will never ever give birth to a chicken. And then with a 1, we say on that example of a cow giving birth to a chicken, so it is 0. There is no chance of that happening. And then if I ask you, if I tell you that 1 stands for probability of an event that will certainly happen, a probability of an event that will certainly happen. It's 1. If I say a chicken is going to lay eggs, it's true. There is 100% chances that chicken is going to lay eggs. There is 100% chances. So now you can't say there is 0 chance of a chicken laying an egg. No, a chicken is the one that lays eggs. So a cow cannot give birth to a chicken, and a cow cannot lay egg. So that means only a chicken can lay eggs. So 1 stands for, meaning there is that chance. We are so certain that this is going to happen. But with the 0-1, there is no chance of that happening. That is what we are referring to. This is the probability scale that I was referring to, boys and girls. Look at this. We say here it is 0. Meaning 0, it goes together with the impossible. So it won't happen. There is no way a cow is going to give birth to a chicken. There is 0 chances. Nothing. With an unlikely, then we are saying we are there. As you can see, remember I said on a probability scale, if it is 0 to 1, then it will be a quarter here as a fraction, and then in the middle it will be half, or likely, meaning a quarter it is unlikely to happen, and then with 50% or with a half, there is 50-50 chances. We usually say there is half chances of an event happening. It can happen, it cannot happen. And then if it is a 3/4, meaning it is going way. Look at this. If we say impossible, it is right at 0. And then with likely, it starts to move a bit. And then 50% chances, that means it is here, right in the middle. So it can happen, it cannot happen. But with a 3/4, so even here, if it's an unlikely, as you can see, impossible, it's not happening. But with unlikely, then it's going there. So meaning it's unlikely to happen. So there is a possibility of it going back, reversing. And then with the 50-50 or half, then we say it can either happen or it won't happen. And then likely now, it's going to happen. It's going way. It's going this way. That means it's getting to what? To certain, whereby it's going to happen now. It's going here. It's going to 1. If we're talking about the scale of 0 to 1. So when we talk about 0 to 1, as you can see here, we say 0 is impossible. On a quarter fraction, then it's unlikely to happen. And then with a half, remember I said it's 50-50. With a 3/4, meaning it's closer to happening. It cannot happen, but it's closer to happening. So that means there are chances that this is going to happen, likely to happen. And then with certainty, now we are so certain that it is going to happen. And then if they say now write your answer as a decimal, this is what I was referring to. As you can see, 0 is impossible. And then because now it's a decimal fraction, it will be 0.25. And then your half is 0.5, and your 3/4 now is 0.75, and then here we have 1, because now it is a whole number. It's the meaning it's certain that it's happening. And then as a percentage now, as a percentage, it will be 0%, and then we say it's 25%, or 50%, 75%, and 100% of an event happening. So if we are certain that an event is going to happen, we say it's 100% that is going to happen. But if we say we are sure that this is not going to happen, we say it's 0% or it's zero because it's impossible. That won't happen. But if we are sure but not that sure, there is likelihood of not it happening. So meaning there's a greater chance of an event not happening. So we say it is what? It is unlikely. And then if it's 50-50, then it balances. It can happen, it cannot happen. And then with a likely, there is a greater chance of an event happening, less than the greater chance of an event not happening. So there are greater chances of an event happening that is greater than, there is meaning 75% of that, and then less than this one of not happening. As you can see, from 3/4 from here going back, it's very far from the 0.75. So going back there to 0 is very far. So meaning there are less chances, very less chances of an event happening. So but going there to 1 is very near. So that means there is a chance of an event to happen. I hope you understood this probability scale, boys and girls. And once you can understand this, it's so simple. When they say write your answer as a fraction, when they say leave your answer as a fraction, and then okay, this is what they're expecting, a half as a fraction. And then if they say write your probability in words, then you'll be mentioning the impossible, the unlikely, the equal likely to happen or not happening, and then the likely or certain when they say in words. And then when they say as a fraction, it's half. And then as a decimal, we know half is 0.5. And then as a percentage, it is 50%. That is all about the probability scale. Boys and girls, I hope you understood the terminology and the probability scale. Now let's see the examples. Before I can even go to the examples, let me just conclude with these two. This is the first one, the theoretical probability. Remember, theoretical, meaning we do it, meaning it's theory now, we have to carry it out. We use known facts about the probability or the situation. So with theoretical, we use the known facts about probability or the situation. No experiments are conducted at all. It says no experiments are conducted, but knowledge about the situation is gained by logical reasoning or known formula. So meaning with theoretical probability, we don't need to conduct any experiment, but what we do, we use the knowledge about the situation gained by using the logical reasoning, meaning you can give a logical reasoning for your answer, or you can use a formula. And then the formula that is used to calculate probability of an event, it is this one. Theoretical probability, it is the number of favorable outcomes over the number of possible outcomes. Remember when I was talking about tossing a coin. As we toss a coin, we expect what? A head, or we expect a tail. So we are expecting those two when we do what? When we toss a coin. So if I can take that into the theoretical probability, I know that when I toss a coin, there are two possible outcomes. The number of possible outcomes, they are two, because here there are two. It is head or a tail. But there is only one favorable outcome, meaning as I toss a coin, I won't get head and tail at the same time. I am only going to get one answer. So it's one there. So this one, it's a favorable outcome of tossing a coin. So it means if I get an answer of a head, then it will be a head over what? Over a head or tail. So that means it will only be one. It can either be a head or it will be a tail over head or tail. So the number of favorable outcomes is only one, and then the number of possible outcomes, there are two. Now, maybe let's take again when I roll a dice. When I roll a die, one die, meaning one die, I will show you, it's one dice. We usually call it a dice, but it's only one die. And then when there are dice, there are two. So when I roll a die, I'm expecting only one outcome, meaning the favorable outcomes, it will be one. If I ask you, as you roll a die, what is the probability of you getting a 6? So we know that in a die, it's 1 up to 6. And then when I roll it, I don't know, I might get a 1 out of what? Out of 6, or I might get 2, or I might get 3, or I might get 4, or I might get 5, or I might get 6. So it means there is only one chance of me getting that answer. I won't get a 7. I've got only one die, and then as I roll it, then I'm expecting to get my answer to be 7. No, it's impossible. That won't happen. But if I ask you, what is the probability of getting your answer as 1? Then you know when you roll a die, 1 is there. There is a favorable outcome. Out of what? Out of 6 possible outcomes. Remember, it's 1 up to 6. Now, let's have a look at this example. A jar containing 7 red balls and 12 blue balls. A jar, here's our jar here. It contains 7 red balls and 12 blue balls. Now the question says, determine the probability of picking a red ball. Now, how many balls do we have? We have 7 red balls. And then, how many now are the blue balls? There are 12 blue balls. Now, for us to get in total, remember we say the number of possible outcomes. In total, how many balls do we have in our bottle? That means we are having 7 plus 12. That gives us what? 19. So there are possible, how many possible outcomes? 19. But for me to get a red ball, there are only 7 chances because there are only 7 red balls. If there were 13 red balls, then I would say possibility of me getting a red ball, it will be 13 out of 19. So now, because they told us that there are 7 red balls in a jar and 12 blue balls in a jar. So all in all, the number of balls in the jar, they are 19. But for me to get the red one, it's only 7 chances out of what? Out of 19. So here is the answer towards that, because now they said determine the probability of picking a red ball. Then this is your answer. It will be 7 out of 19 balls. We said the total number of balls, it's 19, and then there are only 7 red balls. That is why our answer, it is 7 over 19. And boys and girls, always remember now, when you answer this probability, you have to write here P, which means it is probability of what? Remember they said red balls. So you say P, probability of red balls. Then you close it, you say equals to, excuse the mess there. So we say probability of P, which is probability of getting red balls, it will be 7 out of 19. Always, don't forget. And now, as you can see, this one, it is in a fraction form. Now, let's have a look at the experimental probability. Theoretical, remember, we are using the known. Now, with an experimental, we have to conduct an experiment. Then that experiment, how do we conduct it? It's through a number of trials. Now, experimental probability, we say found by repeating the event many times, many trials, and then calculating the probability based on the outcomes of these trials. So, meaning with the experimental, you have to conduct it over and over for you to get the answer. So the trial must take time, must take place, and then you'll get the possible outcomes based on the number of trials. Now let's have a look at this question. It says a dice is thrown and the outcome is noted. A dice is thrown and the outcome is noted. Determine the probability of throwing a 3. Now look at this. They are telling us that a dice has 1, 2, 3, 4, 5, 6 on it. And then now the probability of getting a 3 is only 1. Because as you can see, there is only 1 3. And then they ask you, a probability of getting an odd number. Odd number meaning it's that number that is not divisible by 2. It means when you divide it by 2, it will leave a remainder. So which numbers here? When you divide it by 2, it leaves a remainder. Then we have a 3, we have 1, 3, and a 5. Those are the odd numbers. Now they ask you, what is the probability of getting an odd number? It is 3/6. And remember, they said leave your answer in what? In its simplest form. Then you write it as a half. Even numbers, and then we saw our even numbers, it is 2, 4, and 6. These are our even numbers. And then the odd numbers, let me maybe do this so that you can see when we talk about the odd numbers. These are our odd numbers. So there are 3 even numbers out of what? Out of 6. So that is why our answer is 3/6. Probability of getting an even number, it is 3/6. And that means when we leave it in its simplest form, it is a half. Now, boys and girls, remember, we need to know everything that is entailed on probability. We spoke about the tree diagram. We spoke about the definitions or the terminology that is used in probability. And then we spoke about the probability scale. And then we said the probability is written as a number and then it can be expressed as a fraction, as a decimal fraction, and then also as a percentage. And then we just did the theoretical part and the experimental probability. Now we are talking about the compound events. So what are we referring to when we say a compound event? Sometimes in probability, we have more than one event taking place. To calculate the probability in this case, we need to determine all the possible outcomes. And for us to do this, we represent the compound events on a tree diagram or on a contingency or a two-way table. Remember now, what are we doing? We are representing these compound events on a tree diagram or on a contingency or two-way table. And then after doing that, we must be able to interpret and analyze a drawn tree diagram. So meaning you can't just draw a tree diagram, you leave it like that. You should be able to interpret and analyze it. Same applies with a contingency table or a two-way table. Now after doing that, we say we use the drawn tree diagram and a contingency table or two-way table to complete a task. So that means after you have represented that, now you should be able to do what now? To complete a task by doing what? By interpreting and analyzing it. Here is an example, boys and girls, of a tree diagram. Remember I said with a tree, there is a tree trunk and then it has got some branches. Now these are our branches here. These are what you call our branches. As you can see, they branch from where? From the trunk, from the tree trunk. So meaning this is a tree and then all these are the branches of a tree. Now we say a tree diagram is shaped like a tree. So when they say draw a tree diagram, they are not referring to the tree outside, but they are referring to this tree diagram. It has branches that represents the possible outcomes. These are the possible outcomes. As you can see, it's coin tossing, and then these are the possible outcomes, tail or a head. And then we say a tree diagram is visual way of expressing the outcomes, particularly when there are more than two events. It's a visual way because we can see now from our tree diagram the outcomes. So now if I toss a coin, remember I was talking about tossing a coin. This is our coin, and then if I toss it, I can get a tail or a head. I won't get tail and head at the same time. I will only get a tail or a head. So looking at this, meaning tossing first coin, as you can see, from the first coin, then I can get either head or tail. And then on the second toss, remember now I am tossing a coin. I want to get the results. Now I am tossing a coin for the first time. I get either a head or a tail. A head or a tail. Then I'm tossing a coin for the second time. On the second time now, from the first results, I can either get a head or a tail. That goes together with what? With the tail of the first toss. Or I can get either a head or a tail that goes together with the head of the first toss. Now, if I am to repeat it, I will show you when I do it, maybe tossing a coin 3 times, then my tree diagram will be like this. It will be, I'm just making an example quickly, coin tossing, and then this is the first result, which will be a tail or a head. This is the first toss, and then I get a head or a tail. On a second toss with this one, remember now it's a second toss, I will either get a head or a tail. Same applies here. It will be a head or tail. And then I go to the next one. I can also get this one. Now this is the second toss. And then on the third toss, same. From this one, I can get a head or a tail. A head, tail, head, tail. So it's so nice when you do probability because you get to enjoy it, as you can see. Now we have the first coin tossed. We had a tail or a head. On the second toss, head or tail, a tail or head with the head. And then now, what are the outcomes? We're talking now about the outcomes after tossing this coin. What are the outcomes? Our outcomes will be tail, as you can see. These are the outcomes. We have a tail here. It goes together with this one. That is why we have tail. And then here, because it is a tail and a head, and then you say tail, head. And then on the head part, now maybe your coin, the first coin was on a head, and then you can either get a tail or a head. Now the outcomes for that one, it will be head, tail. So it means it goes this way, a head, tail. And then on this one, it will be a head, head. There are two heads. Now let's have a look at this one that I have drawn on the side here. Pardon me, maybe I did not start with the tail with the same pattern. Now let's have a look. Here I will have a tail, head, head. So meaning my outcome for here, it will be a tail, head, head. And then on this one, the first one, here, from here, it will be 1, 2, 3. And then here, because remember now I've tossed the coin 3 times, and then it will be a tail. What I'm expecting here, my outcome, it will be a tail, a head, and a tail, the combination. On this one, I get this combination of tail, tail, head. And then here I have tail, tail, tail. And then on this one, I have a head, head, head. Meaning this is my outcome, whereby I get the head, head, head. And then I've got head, head, tail. Head, head, tail. And then on this one, I have head, tail, head. Head, tail, head. And then on the last one, I have head, tail, tail. I have head, tail, tail. So all these, we call them now what? The outcomes. So how many outcomes? On tossing a coin, maybe you're doing only one trial, tossing a coin only once. Then we have only 1, 1. And then on the second one, as you can see now, we have tail, head, tail, head. And then now the outcomes will be tail, tail. These are the outcomes. And how many possible outcomes? It's 1, 2, 3, 4. And then on tossing a coin 3 times, then how many outcomes? It will be possible outcomes. It will be 1, 2, 3, 4, 5, 6, 7, 8. Here it's only 4. Here we've got 8. So boys and girls, once you understand this, you are able to get the results. And for you to get the results, you follow the pattern to say, okay, fine, here it is a head. And then if they ask here, then it's a head. It goes together with this one, with this head. And then I get what? A head, a tail, tail. And then, sorry, with this one, it is a tail. And then it goes together with this head. Now I've got what? It goes like this. It will be a head. It will be a tail, head. That means my outcomes will be tail, a head. So you need to follow the pattern in order to be able to answer this. Don't just write because now you are given the information. You look at the information and then you follow the pattern of the tree diagram. Where does this branch start? It starts from here, and then from here it splits into 2, and then these are the other branches. So you follow that. You don't just mix the branches. They follow one another. Now a two-way table. With a two-way table or a contingency table, we say a two-way table is also called the contingency table. And then a two-way table that shows all the possible outcomes of 2 trials taking place together. And it has how many outcomes? It has the outcomes of one event across a row in a table, across a row in a table, and the outcomes are found on running down, meaning the outcomes are like this, in a row and then also in a column. So as you can see, we've got 2 spinners, spinner 1 and spinner 2. Spinner 1, it can be labeled as, let me say you label the spinner as 1, 2, 3, and then the other one it will be ABC. So spinner 1, as you can see there, we say spinner 1. If I spin 1 and then I get the outcome A1, and then if I spin it, then B1, and so on, because it is spinner here. And then same applies with here, same applies there. As you can see, it says spinner A1. As you can see, it will go across if I use the spinner spinner 1, and then spinner 2. As you can see, it's A2, B2, C2, and D2. Spinner 3, or maybe spinning for the third time, A3, B3, C3, and D3. Boys and girls, it's so simple. You can understand this, because now remember, if I have a dice and a coin, so I know that the coin, I can even translate that into a tree diagram. So I know that a dice has got 6 numbers, 1 up to 6. And then a coin, it has a head or tail. So that means first, when I throw a dice, then I can get a 1, and then I toss a coin. I can get either a head or a tail. That means I would say one of a dice, it can go together with what? With head or tail. And then same applies 2. It goes same way, head or tail, and so on. So that is a way of representing a two-way table in a form of a tree diagram, or way we can use it, a contingency plan, as I have explained. Let's go to the questions, boys and girls, because I'm looking at the time and I want us to do as many questions as possible, so that we know we have practiced this probability. Now it says Peter visits his aunt in California. Peter really wanted to go and watch a movie, so his aunt took him to the cinema. Peter was amazed when he saw the following combos he could choose from. Study the combinations and answer the questions that follow. There we have our ultra combo, super combo, treats combo, junior combo, sweet combo, and kiddies combo, or kiddie combo. So there are 6 combos that Peter saw there at the cinema. And then now let's check the questions. Now it's question 1 says, what is the probability that, look at this, what is the probability that Peter will choose a combo with popcorn? Write your answer as a fraction. Peter will choose a combo with a popcorn, and you must write your answer as a fraction. Let's have a look at our combos. We said we have combo 1, ultra combo. It has got popcorns. And then combo 2, super combo. It has got popcorns. And then treats combo. Are there any popcorns? No. And then junior combo. There are popcorns. Sweet combo, which is combo number 5. Are there any popcorns? No. And then kiddies combo. There are popcorns there. Now, how many chances, or what is the probability of Peter choosing a combo that has popcorn? So we say P popcorn. We check, okay, it's 1, 2, 3, 4. So meaning probability of choosing a combo that has got popcorns, there are 4. And then out of how many? Out of 6 combos. And now they say write your answer as a fraction. This is our fraction. Are we going to leave it as it is, boys and girls? No. Always leave it in its simplest form. It can be stated that leave your answer as a simplest form, or write your answer in its simplest form, or not. So even if they did not mention, you can just leave it in its simplest form. So now we want a number that can go into 4 and 6 without leaving a remainder. That number is 2. So 2 goes how many times into 4? It goes 2 times. And then into 6, it goes 3 times. Then because they said write your answer as a fraction, that's where you leave it. Our answer is 2/3. So meaning there are 4 combos that contains popcorns out of the 6 combos, and then our answer becomes 2/3. The next question, it says, what is the probability of choosing a treat combo? Now you see what I'm looking at. Remember the first one, it was saying a combo that contains popcorns. Now this one, it says a probability of choosing a combo that is a treats combo. Now looking at this, write your answer as a decimal fraction and round it to 2 decimal places. So they're instructing you that you must write your answer as a decimal fraction, and you must round or you must leave it or round it off to 2 decimal fractions. Now let's have a look. It says, what is the probability of choose a treat combo? So now we have ultra combo, super combo, treats combo, junior combo, sweet combo, and kiddie combo. So how many treat combos? We have only one, which is number 3. And then now, because we want our answer, we say P treats is equals to 1 out of what? Out of 6. But this is in a form of a fraction. Now you go to your calculator, boys and girls. We say 1 divided by 6. It will give us what? Our answer is 0.1666666. So it's infinite. And then because they said round off your answer, or yes, round off your answer to 2 decimal places, our answer will be 0.17. Because now remember, rounding 6, it will affect this one. This 6 will affect this. It becomes 0.17. You see, boys and girls, it's very simple to answer questions based on probability. Now, let's have a look at this one. South African wine has a history dating back to 1659, with the first bottle produced in Cape Town. Below are some of the highlights of the 2020 statistics for the year 2019, published by South African's Wine Industry Information and Systems. Now the first question, it says, calculate the percentage of Denmark. Let's have a look. Where is our Denmark? Here is our Denmark, and we know that a pie chart as a whole, it must give us 100%. So now Denmark, we have the percentages for all these other places. Now we want to know for Denmark. How are we going to determine the answer there? Then the percentage for Denmark, it will be, we can say 100% minus, and then you put everything. You say it's 35. I'll start with the United Kingdom. It will be 35 plus Germany 26 plus France, which is 12, plus Sweden is 9, plus Netherlands. Now remember, we are looking for Denmark here. So let me say D is equals to, and then now we are skipping Denmark. Netherlands, it is 5 plus other, which is 6. And then let's quickly add there so that we get the answer. It will be 35 plus 26 plus 12 plus 9 plus 5 plus 6. That gave us 93. So that means for Denmark, D is equals to 100%. Remember, all of this is in percentage. This 100% minus 93%, that leaves us with 7%. So meaning Denmark is 7%. Number B, determine the probability that wine exported to France as a decimal fraction. wine exported to France. Now we go into our pie chart. Here is our France. And then what is the percentage there for France? For France, they said the percentage is 12%. And automatically, we know that percentage 12% is the same as 12 over 100. So when they say write the answer as a fraction, it's so easy because already you are given the 12% and then you just write 12% as a fraction. You know the percentage sign, it means it is over 100. Then you just simply write it as a fraction, as a decimal fraction to be 12 over 100. Oh, sorry, pardon me, because they said as a decimal fraction. So it is 12 over 100, and then as a decimal fraction, then you go to your calculator. We say 12 divided by 100. It will give you 0.12. This is our decimal fraction. So now here it is as a fraction, now as a decimal fraction. This is our answer that they're looking for. Write your answer as a decimal fraction. So boys and girls, you see now we are playing with the figures here. If they say decimal fraction, you are given the fraction as a percentage. Now they wanted you to write it as a decimal fraction, and then you just say convert it to what? To the fraction, and then say, okay, then from the fraction, I just say 100 goes on times into 12, it doesn't, then 0, then into 120, it goes there 12 times. That is where our answer comes from. But because now we are the grade 12, so we can simply use the calculator to get the answer. Boys and girls, let's have a look at this one. While driving to Ignative Theatre, Dr. Brooks decided to listen to some music. He has a CD pouch containing the following types of music. He has the CD pouch containing the following types of music. He has 6 CDs containing the jazz, 2 CDs with opera music, and then 4 CDs with classical, and then 12 CDs with instrumental music. Now the question says, what type of music has the highest probability of being chosen randomly? What type of music has the highest probability, meaning has the highest chances of being chosen randomly? So looking at this, we've got 4, 6 jazz, and then 2 opera, and then 4 classical, and 12 instrumental. So the highest here, it will be the instrumental. So our answer is instrumental music. So now it's so easy. You are just reading the information because now they said highest probability of being chosen randomly, because this instrumental music, it has got more CDs in a CD pouch. There is a likelihood or a chances, 100% chances of being chosen because it has got more. Now with number B, it says determine the probability of randomly selecting a CD with hip-hop music. How? Let's have a look here. Do we see any hip-hop? Number 1, I can see jazz music, opera, classical, and instrumental. I don't see any hip-hop. And the question says, determine the probability of randomly selecting a CD with hip-hop music. So looking at the pouch, the CD pouch of Dr. Brooks, I don't see any hip-hop music. So we say P, probability of hip-hop, choosing a hip-hop music. Then it is 0%, or we can say 0, or we can say impossible. So meaning there is no way that Dr. Brooks can choose a hip-hop music because there is no hip hop CDs in his CD pouch. Where do I go?
Excellence.
Oh, there are some glitches
Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you're gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence.
Okay, boys and girls, sorry about that. Now we're busy with the hip hop music, so like I said to you, looking at Dr. Brooks' CD pouch, there is no hip hop music there, so we'll say probability of choosing a hip hop music, it is 0% or 0, or we say it is impossible. Let's continue. Now we say, what is the probability, number C, what is the probability that Dr. Brooks will randomly choose a CD with jazz music? Now we are looking at jazz music. Write your answer in decimal form. Now it says write your answer in decimal form. Now, for the jazz music, let's have a look. The total number of CDs that Dr. Brooks has in his music pouch. And then we have 12 here. Let's start from the top. We've got 6 plus 2 plus 4 plus 12. So meaning the total number of CDs, will be 6 plus 2 plus 4 plus 12. All in all, it gives us 24. So Dr. Brooks, in his pouch, he has got 24 CDs. Now we want to know the probability of choosing a CD that is a jazz music. Now, jazz music, how many CDs of jazz music? There are 6 jazz music CDs. And then we say P, probability, jazz. And then we said there are 6 CDs of jazz music out of the total number of jazz music, out of the total number of CDs in the pouch, which is 24. And then they said we must write our answer in a decimal form. So now if I write my answer, it will be 6 divided by 24 in a decimal. You use your calculator, and then I get my answer to be 0.25. Because they said I must write my answer as a decimal. So it will be 0.25. Can you see, boys and girls? I'm just playing with the figures here. I am given the information, all that I need to do. I look at the question there. They want CD, probability of choosing a CD that is jazz music, and there are only 6 jazz music CDs in a pouch. And then out of what? Out of the total number of 24 CDs. Looking at this one, boys and girls, as you can see, I've started with the popcorns. That means you'll be given a scenario, or the probability question will come out of the question that you'll be answering. Now looking at this one, it's a map. And then on our map there, they say explain why the probability of randomly selecting a museum from the tourist attraction on the map is 1/5. So now these stars on the map, as you can see here, these stars, they indicate what? The tourist attraction. So how many stars we have? We have this one, which is the first one to be the War Museum. And then we have another one here, King's Park. We have another one, Stadium. And then we have another one here, White House. Is there any other? We have 1, 2, 3, 4. Okay, we have the Orchard House. There are 5. But out of these 5 tourist attraction, remember, you'll be given the indications or maybe the annotations to say this star stands for the tourist attraction. So it will be indicated in your question paper. So it's easy for you to answer the question. You just look at that, you say, oh, okay, because this stars stands for the tourist attraction, but now the question says museum, selecting a museum from the tourist attraction on the map. Why is it 1/5? So as you can see, I've circled all the tourist attraction, but there is only one, that is a war and museum. So that is why our answer, it is 1/5. There is only one museum attraction, or maybe tourist attraction. There is only one museum, a tourist attraction out of 5 tourist attraction. So it means there are 5 tourist attractions on the map, but only one, it is the museum attraction. So that is why our answer, that is why there is a possibility of only 1/5 of the museum attraction. Now, boys and girls, let's continue. Remember, I said I want us to do as many examples as possible. Now let's have a look at this one, at this tree diagram. A tree diagram alongside shows the different options available for the candle that will be sold. Use the tree diagram alongside to answer the questions that follow. So this is a tree diagram. It is a tree diagram for the different candle options. So in that store, they're selling the 2 types of candles. They have the cylindrical candle, and then they have horsehead candle. And then the cylindrical candle, it has a white and a gold ribbons, meaning. So it has a white or a gold ribbons. So here it says the decoration, or it has 2 colors. Sorry, it's a candle, cylindrical candle with 2 colors, white or gold. And then the decorations, it is with a ribbon or without a ribbon. Now look at this. They are giving us a clue in our outcomes. As they give us a clue, now we have the cylindrical one, and then this C stands for what? For the cylindrical. This W, so meaning C for cylindrical, W for white, R for ribbon. That is why we have the outcome as CWR. So this is from here. CWR. It goes this way. So now, for number 2, it says candle, cylindrical candle with white ribbon, and then N stands for no ribbon. So this one, it goes this way with no ribbon. And then the gold one, same applies. It is a cylindrical candle with a gold ribbon, with a gold color, and then it has a ribbon, CGR. And then the next one, it's cylindrical. The next outcome, it will be cylindrical candle with a gold color and no ribbon. Now, The next one, it's a horse head candle. With a horse head candle, it has white color. Remember the two types of candles, is cylindrical and the horse head. Now the colors is white and gold. With the horse head now, it is white and black. They are no longer talking about gold, but it's only white and black. Now let's have a look at the outcomes. Now the outcomes for this one, it's a horse head, and then we have white, and then it has a ribbon, HWR, meaning for horse head, white, and a ribbon. And then the next one, it will be horse head, white, no ribbon. This is the outcome. And then now we have the horse head, black, and then remember now it says ribbon. Now they want to know, write down the description for X. Looking at this, under the decorations, we have ribbon, no ribbon, ribbon, no ribbon. You just follow the sequence. The top part, the top one says ribbon, the other one no ribbon, ribbon, no ribbon, ribbon, no ribbon, meaning here it will be ribbon for X. X here, it will be ribbon. And then now we go to the next one. It's a horse head, black in color, no ribbon. What will be our outcome now for Y? For Y, it will be horse head, black, and no ribbon, meaning it is horse head, black, and no ribbon. These are the outcomes. You see, boys and girls, it's so easy to get the answers. You don't need to scratch your head. You just follow the pattern and then you get your answers. Let's have a look at this one. A tree diagram alongside shows the different options available for the candles that will be sold. Use the tree diagram alongside to answer the questions that follow. Write down the probability of buying number one, any candle with ribbon as a percentage. Any candle, so irrespective, with a ribbon as what? As a percentage. Now you go back to your tree diagram. We said we have a cylindrical candle and a horse head candle. Now with a ribbon, how many? So we have cylindrical candle, white with a ribbon, it's 1. We have cylindrical, white, no ribbon. Cylindrical, gold, ribbon, it's 2. And then we have cylindrical, gold, no ribbon. We have horsehead, white, ribbon, it's 3. And then we have horsehead, white, no ribbon. We have horsehead, black, and then here we said ribbon, it is 4. Horsehead, black, no ribbon. So now a question says, write down the probability of buying a candle, any candle, with a ribbon. So it will be P candle, ribbon, which will be 1, 2, we've got 1, 2, 3, 4. So it will be 4 out of how many possible outcomes? 1, 2, 3, 4, 5. Let's see, it will be 1, 2, 3, 4, 5, 6, 7, 8. So that means it is 4 over 8. So out of, if the answer is 4 over 8, and then they said write it as a percentage, we just multiply it by 100%, and then we get our answer to be 4 divided by 8 multiplied by 100, which is 50%, because they said write your answer as a percentage. That's how you get your answer, boys and girls. Now the next one, write down the probability of buying, number B, a gold horsehead candle without a ribbon. So it will be P gold horsehead without a ribbon now. Without a ribbon. Now you go straight to the horsehead candle, and then they said without a ribbon. There are two. So it is, we have one, it's horsehead without a ribbon, even this one. So meaning there are two out of what? Out of the 8 chances. So the answer, it is 2/8. Boys and girls, I'm just doing this question because our time is up, but let's quickly finish this question so that at least you know how to attempt answering these questions in the exam. As you can see, this is type of the question that is so simple. Now here, as a loyal supporter, Sarah bought the following: a cheetah cap, a shark cap, and then cheetah t-shirt, shark t-shirt, cheetah scarf, and a shark scarf. Now they are given the abbreviations SCC, SC, and so on. So now it says the following tree diagram can be used to determine the number of combinations. To determine the number of combinations Sarah can make when wearing a cap, a t-shirt, and a scarf. Let's quickly answer this one and then we close it. And then now we say, write down what should be on the tree diagram in the place of each of the following. Number A, remember, we spoke about the t-shirt and so on. Now here it is the shirt, the shark cap with the shark t-shirt and the shark scarf. And then here we have the shark cap with the shark t-shirt and the cheetah scarf. Here we have a shark cap, and then we have a cheetah t-shirt, and now here we have what? We have the shark. We have the shark shirt. Now we look at this. We have a shark scarf. Now we want to know number A. Here's our A. A, we have the shark scarf, the cheetah t-shirt, and now we have the shark. It will be the shark t-shirt scarf now. So meaning here we are only waiting for the cheetah scarf. As you can see, it will be the CT for A. We are missing one. We have the scarf, we have the cheetah scarf, we have the cap, the t-shirt, and the scarf. And then we have the scarf, the shark scarf, the cheetah t-shirt, and then we have the cheetah cap here, which is SCS. That is the answer that we are expecting. So our A is CS. And then for B, it will be all the outcomes. Now for B, what are the outcomes? So here it will be the outcomes for what? For the shark scarf. And then for C, let's quickly have those outcomes for B. For B, our outcomes, we have SC, and then we have ST, meaning here, and then we have SS. And then we come here, which will be our SC, ST, CS. And then here we have our SC, CT, SS. These are the outcomes for B. And then we have this one as SC, CT, and CS. And then for number C, boys and girls, it will be the outcomes for the cheetah cap. So for the cheetah cap here, we say, we'll mention the same outcomes: CC, ST, and SS, and so on. So you just mention all the outcomes there. So these are the outcomes. Number A, it is the outcome for here, and then for number B, now we are writing all these outcomes, and then same as number C, whereby we'll have the CC, ST, CS, CC, CT, SS, CC, CT, and CS. Boys and girls, our time is up. I wish I could have finished explaining all this question of question 5. As you can see there, it shows us that it is the shark cap, the shark t-shirt, and the cheetah scarf. So next time when we meet, we can continue from here, or we'll just wrap it up. But don't forget, probability in a question paper, it will be there in paper 1 and paper 2, and it's not a standalone question. It is being integrated in the questions from question 1 up to question 5. So at any given time in all the topics. So expect to see the probability in the question paper. And just remember that as you answer the questions based on the probability, you look at information that is given. And then if they say your answer must be as a fraction, you know, it will be, for example, half, 1/2. And then if they say write your answer as a decimal fraction, it will be 0.5. And then if they say leave your answer as a percentage, and then you just multiply it by 100. You multiply your probability by 100 to get the percentage. Don't forget, boys and girls, this is where you need to collect the marks in the exam, on the portion or on the section of probability. Thank you for watching today. Let's hope you have gained a lot, and stay safe. Remember, COVID is still out there. Stay safe. Wash your hands time and again, and be there until we meet again next time. Bye-bye.